Please welcome developer advocate from Google, Fred Soar.
こんにちは. So today I would like to talk to you about Google Cloud Platform services. There's 4 services that I want to cover. You heard already about the first one in the keynote this morning, Google App Engine for Business. The other 3 are infrastructure as a service. So let's start with a summary of Google App Engine for Business. First, we should ask ourselves, what is cloud computing? There are many definitions, but the industry has really standardized on these 3 layers: software as a service, platform as a service, and infrastructure as a service. Google has offerings in each of these layers. Google App Engine is in the middle, a platform. Of course, at the top, we have Google Apps, which includes Gmail and Calendar. We have third-party applications from the marketplace. And most importantly, we have your applications that you develop. Many of these applications, maybe you want to build them on App Engine with Google App Engine for Business. Today, I want to talk to you about the middle layer and the bottom layer. You really shouldn't be worried about the hierarchy. We just use services in one layer to create the next layer. So App Engine was designed with 3 main tenets in mind. Make it easy to build, manage, and scale your applications in the cloud. We like to joke and say, we wear pagers so you don't have to. So we have built this enterprise platform on which sits Google Apps. We have the Google Marketplace, where third parties can provide applications for you to install. But there's one piece missing from the puzzle. And that piece, of course, is your applications, which are unique to your business. For that, we launched Google App Engine for Business. This is the same scalable platform as Google App Engine, but it has a few unique features for the enterprise customer. These are the highlights: a centralized domain console to manage all of the apps within your company, enterprise service level agreement, and premium developer support. What's really exciting is hosted SQL. This is a MySQL database running in the Google Cloud. So you can write your application on App Engine, and you can access the Scalable data store or the MySQL database, all in the cloud without having to manage any servers or any databases. SSL, also for custom domains. And pricing specifically for the enterprise, based on number of users using each application each month. Now, App Engine today has about 90,000 active developers building applications each month. 130,000 applications is what they have developed. And together, I'm sorry, this number is old. It's so 700 million page views a day. That's 5.5 billion page views a week. That's the number I talked about this morning. that's kind of a recap of App Engine for Business. What I want to share with you are kind of the other services, the newer Google Cloud offerings. I want to start with the most straightforward one, which is Google Google Storage for developers. Taking your data, your blobs, maybe your media files, your backups, or whatever data that you want to store, and put it in the cloud. It's any format of data, any amount of data, stored for any amount of time. You control the access permissions to the files. You can make the files public and use it to host media files directly. You can share the files with partners or vendors to make it like an FTP Dropbox. You can also make the files private and use them only for yourself. You can access any of these files via Google APIs or several third-party tools. I already mentioned some of the use cases, like the backup and static content hosting. You can also use it for data storage for your applications. Maybe you're building an Android application, or maybe a sharing website, and you need lots of scalable storage in the cloud. You can use Google Storage. Finally, to use the other APIs that I'll talk about today, the prediction and BigQuery, you will need to use Google Storage to get your files in the cloud. I'll talk more about that later. So some of the benefits are that you're using Google's global network infrastructure to host these files in the cloud in a very redundant way. If you set the appropriate cache control headers on these files, they can be served very efficiently at the edges of our network, very close to your users. Because users, when they connect to Google, they're always connecting to a data center that's very close to them, even if the service itself is running in another data center far away. The requests travel over the Google network, over our network backbone, and we can perform many optimizations that are not possible on the public internet. Now here are some of the technical details that you're probably most interested in. There's a RESTful web interface with many verbs, not just get and put. Each resource that you store is identified by a unique URL. The API is compatible with Amazon S3, so you can take many of the existing tools and use them very easily with App Engine. The model is quite familiar. We have any number of buckets. There's no hierarchy. These are flat buckets. And you set access permissions on each bucket. Inside the bucket, you can have a very large number of files with the directory structure. Objects can be of any type, and each individual object can be up to 100 gigabytes in size. And you have two ways to authenticate. You can provide an access key in the URL to have an easy link, or you can use Google accounts to sign in and authenticate in the web browser. All data that you store with Google Storage is replicated to multiple data centers in the US. In the future, we hope to expand the replication to other data centers. But leveraging our global network, and if you set the appropriate cache control headers, that data may in fact be served much more quickly than you would expect. Bucket names are controlled by a namespace. So you have to show ownership of a domain name before you can use a bucket with that domain name. This provides a great way of segmenting the namespace. we have a consistency model which is called read your rights. This is very important. This is not eventual consistency. You might be familiar with eventual consistency, which is I write my data, and then I perform a read, and I may see stale data, or the data may not be visible yet. There's some delay before I know for sure that I can read the data. This often means that we push the data out, and then we have to wait a few minutes to be sure that we can serve it. With Google Storage, once you put an object in Google Storage, no matter where in the world you read that object, you will see the right that you just put. So that's what we mean by read your rights. We also offer range gets, which means getting a portion of the files, some subset. So I said sharing with individuals and groups, access controls, not only on buckets, but also on individual objects. And you can set read and write permissions or view permissions. Now, to get you started easily, we have a couple of tools that you can use. We have the Google Storage Manager, which is a very simple browser-based user interface to view your data, scan through buckets, create buckets, upload files, and download files. And we have a command line tool called gsutil. This is a very easy tool to use. It works just like Unix commands. You can do a gsutil copy, gsutil rm to remove a directory. Works the same way. Now, there's many users of Google Storage already inside of Google. I mentioned BigQuery and Prediction API, but we also have some other services that you see listed here. In addition, we have many early adopters outside of Google that have started to use Google Storage in their deployments. You're probably quite interested in the pricing, which you can see available online. The storage is simply gigabytes stored per month, and then network usage for uploads and downloads. And at the very bottom, you see that gets and puts, there's a small price in addition that you pay, so 1 cent per 10,000 or 1,000 requests. So each 10,000 requests charges 1 cent. Now, Google Storage is currently in limited availability, in preview mode. You get 100 gigabyte storage for free and 100 gigabyte network transfer for free. There's a wait list to sign up for. And if you let me know, we can maybe set you up with a test account. You can store any kind of data in Google's cloud with easy-to-use API. You can use some of our tools out of the box or many of the existing tools that are out there. And because it's a RESTful web interface, you can write your own tools. The third service I want to talk to you about is the Google Prediction API. This is about predicting the outcome of a certain data input. I'll start with a simple example. Let's say you want to guess the language of an email that you've received. Maybe your company provides support to users in many countries, and you want to know which support person to redirect the email to. You can train the Google Prediction API to guess the language of the email. Let's say you get an email with the text that you see there, and through a web interface, the Prediction API will give you the answer and say, I think this text is French. So how do we do this? Well, we use very sophisticated machine learning techniques. We actually choose multiple algorithms in parallel and then execute the one that we believe will work best. So if I want to do this, it's a two-step process. I first need to train the API with my data, and then I can ask it for predictions. There at the top, you see that I have given the API 4 examples. I've given it 2 English sentences and 2 Spanish sentences. These would be provided in a CSV file. The first column contains the answer that you want, the category. Once we've trained the API, we can ask it questions. So we can feed it the 2 sentences you see at the bottom, and the API will give us an answer. This really has a lot of different potential use cases, and there are many more use cases that we even haven't thought about, that maybe you have thought about. So here's an example that I started to talk to you about. A large company needs to respond to customer emails in the right and appropriate language. So they have many emails from the past that they correctly routed to the right language, the right support team. They can take all of that data that they have collected and created, and they can use that to train the API so that you can now automatically route emails for your users. So let's look at that. Simple process. Upload your training data to Google Storage. Then build a model from the CSV file that you provided, and then make predictions. So this is what a CSV file might look like. The first column, again, has the desired outputs. The remaining columns are the inputs. To upload to Google Storage, you can use gsutil with the copy command, cp. And you see there's a special URL for Google Storage, gs. Then the name of the bucket that you have created, and then the name of the data file, the object. In step 2, we train the model. This is a RESTful web service. So we make an HTTP post. We give it the bucket name and the object name, and we say, please train using my CSV file. The training runs asynchronously, and you can check back every once in a while to see if the training is done with a get. Once the training is successful, you will receive this type of JSON response. It shows the bucket name, the object, and it provides you an estimated accuracy. The more data that you put into the API, the more accurate the API is able to process the data. So just collect more data, and you can get more accurate results. Of course, what we want is to actually make the prediction. Again, we use an HTTP post. We post the prediction request, and we provide an input. This is a sentence from an email, a brand new email that hasn't been seen before. The API responds and says, that looks French. And you can write your application to route the email to the French support team. Here's a little example in Python how you might do this. The slides will be up online later, of course. So, prediction API capabilities. We have inputs of text, unstructured text, or numeric values. And output, I showed you one category, French, English, Spanish. You can have many outputs. Maybe one output is language, another output is importance, and a third category is type of problem. We use many machine learning techniques, and we automatically select the best one for your data. The training is performed asynchronously. This allows you to upload a new training set to replace the old one while still using the API. Google will process the new data set, and once it becomes available, it will swap out the prediction engine. You can access the API, of course, from many platforms. You can build a Google App Engine app. You could write a script in a Google spreadsheet. And you can write a desktop application, or maybe a mobile application. We recently announced version 1.1 of the API. We have a new syntax. We've added multiple categories and continuous output. This means numeric values on a range. So for example, the importance of an email, you could rate that between 0 and 1. And we allow now for mixed inputs, both numeric and text. Now, I want to talk to you a little bit about BigQuery. This is a fantastic new service which allows you to analyze hundreds of millions or up to billions of rows of data. What you do is you take your existing data, maybe you have a very large set of transactional data, and you upload it to Google Storage, and then you ask BigQuery to import that data, and BigQuery will give you SQL access so that you can access this data in real time or near real time. This is based on tools that we've been using at Google for a long time, but we're now making it available so that you can use it for your applications. It allows you to analyze very large amounts of data in very short periods of time. We have a simple SQL-like language, and we have several access capabilities, like a RESTful API, JSON RPC, and Google Apps Script. We know that working with large data is really a challenge. Oftentimes, with existing systems, we do a lot of batch processing. And this makes the process very slow. I have 100 million rows of data, and I want to find out what are the top 10 complaints. And I have to run a big batch process that takes many hours to run. If we move this data to BigQuery, we can get those same answers in just a few seconds. Now, of course, that's an optimization, and that's great. But there's something even more significant. When you change the speed at which you get results, that, in turn, changes the way that you use the data. It changes what you can do with the data. Imagine that the only way you could talk to someone is over a huge delay. You remember maybe when we had men flying to the moon, we asked them questions, and there was a 3-second delay before they received our transmission. Let's imagine that we send someone to the sun. That's an 8-minute delay. Imagine talking to your friend, and every time you speak, you have to wait 8 minutes for the signal to travel to the sun, for your friend to answer, and 8 minutes to come back. 16 minutes. It's really hard to have a conversation that slow. It's really hard to learn about what's going on with him when there's such a communication delay. That's the same problem that exists with large data analysis. When it takes a long time to get an answer to your question of, what are the top 5? What's the most important? What are the outliers? Then it's a long time for you to learn about your data. It's a long time for you to gain insights. And it's a long time for you to make new decisions. So BigQuery allows you to accelerate this process so that you get feedback very quickly on the orders of seconds. And that changes the way that you interact with your data. That changes what you can do. It changes your ability to make decisions. Again, there are many use cases. You can build interactive tools in spreadsheets or dashboards. You can use past data to find occurrences of spam. You can find outliers. You can look at trends. How's the data changing over time? You can do optimizations. So these are some of the key features in BigQuery. It's scalable to billions of rows of data. It's fast response within seconds. Now, you might be wondering, how is it that we can answer SQL queries over 1 billion rows in just a few seconds? When on your own database, that might take minutes or sometimes hours to get those same answers. The key is that we do distributed computation. We take your data, we ingest it into the system, and we distribute that data across many different machines. And then when we issue a query, we can have all those servers in parallel, each process a small portion of the data. And then they can send each of the individual results to one central place. So for example, if we're summarizing the contents of our data set, we ask maybe a few hundred machines, give me the summary of your data. We collect all of those and we summarize that. So each time you execute a query, we process all of your data. That's really an amazing power that we can provide through the cloud. The SQL-like interface, of course, makes it easy to understand how to interact with the system. And a RESTful API makes it very easy to integrate with other web services. The Google Apps script is great for putting this power into a spreadsheet, for example, so that your users can interact with very, very large data sets through a mechanism that they're very familiar with. So how does BigQuery work? Well, again, we upload our raw data set to Google Storage. Then we grant permission to the Google Storage account to read our data. By default, the data is protected in private. So there's actually a step missing here, which is changing the access control after you upload the file to grant access to the BigQuery service. Once we do that, we can tell BigQuery to import our data. So the data is already in the Google Cloud, but it's not in the correct format to be processed very efficiently by many, many machines. So that's why we have this import step, is to take your CSV file and process it and distribute it across many machines. Finally, we get to do the very exciting piece of performing the SQL queries interacting with our data in real time. The SQL queries, of course, look quite familiar. We can select, we can use where clauses, we can use group by and order by. We can limit to the first few rows. We have many common functions. These are just a few. Many common functions on these data types. We also have some special statistical approximations. Sometimes it's not that important to get an exact result. Sometimes I just want to have a rough idea of what the top categories are or what the average might be. Sometimes close is good enough. These special functions will return much more quickly because they don't have to be as accurate. So in the top you see the limit. That's an accurate one. That will limit the results to the first few rows. Top will sort of guess and make a best effort, and in many cases will be very satisfactory. Again, we have a RESTful API. So we can get the table name. We can perform a query through an HTTP GET. And here's an example of result set returned. So let's imagine we said get BigQuery v1, and then in the query parameter we pass in select count from, etc. This might be the result that we get back. It tells us that the column that is being returned is the count star, and it gives us the results. We see here highlighted in red. Use standard Google Authentication for BigQuery. That means the client login, which is the familiar Google Accounts login. We also can use OAuth as an open standard. And AuthSub is an existing API that we also support. Of course, HTTPS to make sure to keep your credentials and your data clear. And we use Google Storage to manage the access permissions. So let's look at what some of these queries look like. Wikimedia has a very large database of all the changes that have been made to the wiki. Now this data is very valuable, but it's very hard to parse in a short period of time. So as an example, we took the Wikimedia data and we uploaded it into BigQuery so that you could try it out and play with it. So here is an example where we want the top 5 titles. And so the where clause has the WP namespace. This is a special namespace that excludes administrative changes in the wikis. So this means all user-performed changes. What do the results look like? We very quickly get our top 5 articles by number of edits. So these are the articles that have had the most individual changes applied to them. Now, this is another way of interacting with BigQuery. We have something called the BigQuery shell. And thanks to the Python DB API and another contributor's SQL command, you can access BigQuery from a command line prompt. You simply type in your SQL queries, and you get your results back. And you can do this from any shell. Now, I talked to you about AppScript, doing things from a spreadsheet. Now, this is where it really gets fun and where it really gets powerful for your users. So imagine that I have a spreadsheet here, and you see at the very top, there's kind of a formula that says import data, and then it concatenates a couple of pieces of information. First, the URL, and second, a query string. And the import data will go out to the web and get some results. Now, the cell that is in the query is called B4. And you'll note that in B4, it currently says no value. The results are listed in rows 5 through 10. On the right-hand side is a chart based on the results. So now what I want to do is I'm going to go into row or cell B4, and I'm going to type the word Google. And that causes the formula to execute. Fetch the data from BigQuery. BigQuery will analyze, execute my query, return the results. The top 5 results are inserted into the spreadsheet. And then the spreadsheet will take those results and put them in the chart. So now, users can type simple queries in one field and immediately see charts in real time. And there you have it, a user interface with AppScript and BigQuery. So to summarize some of these cloud services, we have Google Storage, which is providing high-speed data storage from the Google Cloud, a prediction API, which is using Google's machine learning technology, and BigQuery for interactive, near real-time analysis of very large data sets using SQL. We have more information for each of these products. And of course, Google App Engine for Business has a similar URL. I'm happy to take any questions that you have at this point. Thank you very much. Okay. Hopefully questions only in English, unless someone can offer to translate. Please. Yes, please.
Thank you very much for your presentation. My question is about prediction APIs. Is there any way to export the result of running data to the outside of the storage? So I mean, in your example, to or the is the indicator of English. So that kind of information is available to other account of the storage.
So the training data set is only available to your account. It's your data and your training set.
So you mean there's no way to share the training data from you and me?
We can share through Google Storage the same CSV file. And, oh yes, I'm sorry. Let me repeat the question. So you were asking if it's possible to share the results of the training data. So you upload data, can I benefit from the result? Currently, the only way to do this is for you to give me access to your data file. And then I can do my own training set.
Is it raw data?
The raw data. Grant access to the raw data, yes. Or we could share the same authentication account. Thank you. Any more questions? Yes. Sorry.
On the SQL on SQL for the business app engine.
Okay.
Scale like the normal store, or is that going to have problems with like high volume?
Very good question. Let me repeat. So the question is about the hosted SQL support on App Engine. Will it scale the same way as the data store, or will it have some problems? And so I'm glad you asked that question. So one of the reasons, or the main reason that we created the App Engine data store was because relational databases simply do not scale to very large scale. So when we're providing this new SQL capability, it's simply a MySQL instance, very similar to MySQL running on your own hardware. So it has the same trade-offs, the same benefits of relational, but the same downside of lack of scalability. One thing that we do hope to do in the future is maybe make it very easy for you to have many SQL instances so that you can scale by partitioning or sharding. Today, that's still a problem that hasn't been fully solved. Oftentimes, our developers have to implement this themselves. Thank you. You had a question here?
My question is that, so you categorize the Google storage and the prediction APIs and as the infrastructure as a service. It's kind of storage for me because it's a kind of service and platform for me. So
Yeah.
how do you define the category?
Okay. So to repeat the question, in the beginning I showed, let's see here. One more slide. In the beginning I showed prediction and storage and BigQuery as infrastructure. And why is it here and not in the platform layer? I think that's a good question. And I think the real answer is it's somewhere in between. It also depends on the user. For some people, these are very low-level services and almost like infrastructure. For other people, these are very powerful platform-like features. In any case, I think these are building blocks on which to build your applications, your software. It's difficult to put things in the right place. Thank you. One more question. No more questions. Thank you very much.